Students, for your last and final chapter this semester, Chapter 12, I wanted to go through learning objective number 3 with you and a particular problem regarding that. And this is a time value of money scenarios. The question or exercise is exercise 26A on page 751 for your textbook this semester, being the 4th edition. So go ahead and pause your video right here and please read through the 5 objectives here. Each one of these actually is independent of the next and will be answered separately. So read through those right now. Okay, now that you have read through each scenario, we will go through those. The first one, we're going to invest a sum of $2,500, 12% a year, and what is that worth in 6 years from now? So let's go over and take a look at the solution. So 2,500, we're going to multiply that by our future value factor. And again, you could use, on any of these, you could use a formula or you could use the table factors as given. If we're using the factor, we're using 12% for 6 periods and we get 1.974. So that future value would be $4,935. For question 2, let's refresh our memories what question 2 was related to. So now we want to know how much we need to invest now to be able to withdraw $5,000 at the end of each year for the next 20 years with an 8% interest rate. Okay, so here we're looking at a future value and we're also looking at we're looking at a present value, and we're also looking at a future stream of annuities here. So when we want to do that one, we were looking at an annuity present value factor. Okay, so you have to always ask yourself, am I looking for a present value or a future value? In this case, I'm wanting to know what the money I need today is, so that's present value. And then you also need to look at and ask yourself, is it a lump sum or is it an annuity or stream of payments? In this case, it's a stream of payments. 8% for 20 periods. Multiply that by our annuity factor for the present value factor. We get 9.818. So the current amount that we would need today would be $49,090 given the scenario given. All right, so the next problem, question 3. You want to have $135,000 saved 7 years from now, 6% interest rate. Okay, so this is not an annuity, but it is this time still present value. We want to have what is the present value we need to save in order to get this amount of money in a lump sum in the future. Okay, so using the present value factor at 6% for 7 periods, we would need to invest $89,775 today to have this amount in 7 years given the interest rate that we were given. Number 4, your Aunt Betty plans to give you $3,000 at the end of every year for the next 10 years. Okay, so that's an annuity right off the bat. We're going to invest it at 14%. Well, that's a nice rate of interest. How much will that be worth at the end of that 10-year period? Well, if we're lucky enough to get a 14% rate of interest, we should have quite a bit of money at the end of those 10 years periods because we'll have a nice return on our investment. So we're looking at future value and we're also looking at annuity. So future value of an annuity. Future value factor of an annuity at 14% for 10 periods. So investing that $3,000 every year for 10 years gives us $58,011. Right, then the very last question. You would like to buy a small cabin in the mountains 4 years from now. It's going to be $54,500. And how much money would you need to invest each year? Well, if you're lucky enough to find a home for $54,500 and you're getting an 8% return, then how much do you need to invest in order to have that that amount in the future. So we would look at, I think we're on number 5 now. So we know in this case what we want in the future, right? We can calculate our annuity future value factor of 4.506. This case, though, we have to do a little bit different calculation. We're not just multiplying by the factor, but we're going to divide by the factor, because the future value of 54,500 equals the annuity that we can invest times the 4.506. So if we divide 54,500, we just put that here. If we divide the 54,500 divided by the 4.506, we get 12,905. And that is the end of this particular problem with learning objective number 3. As always, let me know of any questions. Thank you.